Hi, I am Mohit with my teammate Akash and Siddharth, and now I am going to quickly explain what exactly we have encountered in this project. So after importing the data set, what we have did is we created some technical indicators for better prediction, and after that we first started try linear regression. For linear regression we have to remove some correlated data, and after creating the heat map we have observed some highly correlated features which we must remove to start predicting using linear regression. So after dropping some features we have encountered with very few and which will be very beneficial for predicting with linear regression, and after trying linear regression we got the R2 score as 99.99. so it might look good, but actually it is very bad because the close value is so huge and difference between two consecutive close value is so less that it almost predict the same value again, and the R2 score will be close to 99. So after dropping linear regression we try logistic, and even with logistic regression we get accuracy merely 0.51, which is well beyond just tossing a coin and getting 0.5. So it was bad too, so we directly jump to the decision trees to try how exactly decision tree will work. So after trying decision tree, same thing happened, we got the accuracy 0.51. So we thought that maybe trying grid search series to having the best features or best parameters will work, but even after fitting with grid search fit, it failed massively. We try with best criterias like Guinea impurity and max features log to splitter best, so even with that we got the same accuracy. So we got to know that which classing models are not going to work well, so we think differently and we have tried ARIMA. So even after trying ARIMA and making the point stationary, same thing happened. Even we resample the data with 10 minutes to get better accuracy, and after doing all that and trying ARIMA we reached nowhere. We left with almost no response. So now for further explanation Siddharth will explain how exactly we did in deep learning.
So now we start with the DLL models. Uh, we have made a lot of helper functions here. The main thing is that we have a create sequences. So in one go the DL model only takes in a sequence of data. So we are giving in one go only 5 days of data at once. We start by data pre-processing, adding the technical indicators needed, drawing correlations to see how closely the distributions are based. Then we create the sequences, that is in each column we will have the sequence length number of data. After that we scale it using min-max scaler and test train split it in 20% test size. Then we start to make the models. So we are making the RNN model, LSTM model and GRU model. The framework is the same, we have just swapped out the layers, and we compile all three of them once, and we also train all three of them with the early stopping mechanism, which has a patience of 7 and starts from epoch 5 to let the model get used to the data. After that we start by plotting loss versus epoch. So as we can see that the loss has been sometimes decreases and increases, but this is usually because the data is so huge, it will take a lot more epochs. And so we go down now, and we predict the output and inverse transform them into the true values. We get a lot of metrics, but we see that GRU has performed ultimately the best. And we see RNN has a graph, and LSTM and GRU. The difference comes because of the extent of data and the very much changing trends, and we are trying to do it on a 10-year basis, and the trends have changed so much that models cannot keep track of it. GRU has performed the best because it can also remember previous trend and also has a force feed on the previous output. So that's the intuition that we are getting from it.